Okay, let's look at example number 8. This one is about soil compaction. So as usual, feel free to pause the video for a couple minutes and work on the problem, and we'll be back. Okay, so now we're back. Soil compaction is also it's definitely on the testing scope, and so from this problem, we have the Proctor compaction test results. We have the curve, and from the curve, we can find out the maximum density, specifically the maximum dry density. This is really important over here. And we also have the optimum moisture content from the Proctor compaction. So this is about 16%. And as you recall, the Proctor compaction would set basically a baseline to guide our compaction level in the field. And we also have some information from the field testing, typically performed using a nuclear gauge. From the field testing, we have the moist unit weight and also the in situ moisture content. Moisture content looks pretty good, and the question is asking for the relative compaction. So the definition of relative compaction is very straightforward. You can pretty much you can use the reference manual. There's an equation in the reference manual as well, but it's very straightforward, as in we're basically talking about the dry density in the field over the dry density Proctor. Sometimes they would use max because we consider Proctor test would give you the best compaction results. And then time 100%. This one is pretty easy to figure out. This one is essentially that 1.8 grams per square centimeter, but we definitely have to play with the unit a little bit. The gram per cubic centimeter is a density unit, and we would like to convert that density unit to a unit weight, which is kilonewton per cubic meter. We can do that conversion a little bit later. This one is a little bit tricky in this problem because you are only given the moisture unit weight and the water content, but you have to calculate the dry unit weight. So we'll start with the first one, calculating the dry unit weight of the field condition. Well, you can do a three-phase, but I would typically recommend you to remember that equation, that the dry unit weight is essentially the moisture unit weight over 1 plus moisture content. So this equation, unfortunately, is not given in the reference book, but it's a very, very handy equation. So if you have that equation, then we're talking about 18.5 kilonewton per cubic meter. That is the moisture unit weight over 1 plus 16%, the moisture content, and that would give us 15.95 kilonewton per cubic meter. So we figured out that, and then let's move on to the gamma D max, or the gamma D from the Proctor test. Well, again, we only have the density. The density is 1.8. So we have to figure out a way to convert that 1.8 to a unit weight. That 1.8 grams per cubic meter, this is basically the density. That is 1,800 kilogram per cubic meter, right? And then the gamma would be rho times G. That is essentially 1,800 kg per cubic meter times 9.8. That is the gravity. And in this case, I would use the unit of Newton per kg for gravity. And that would give you 1764 kilonewton per cubic meter. So you have this number, you have this one, then the RC is 1595 over 1764 times 100%, and which is about 90.4%. So that is the compaction level, and the correct answer for this one is C. So yep. Okay, so 90%, this is not a great number. Typically, in a lot of field compaction specifications, we would see a number like 95%. Sometimes you would see a number like 98%. So that is usually the target. So 95% is probably a more common one. So looks like the field compaction was not really good for this scenario. Okay, so that is it for problem number 8.